Okay, here we are with lesson 9 for Math 221. And let's start on the preparation. So I guess really, could someone explain like really what the difference is between the null and alternative? I understand that the null is assumed to be true unless there's enough evidence.
Yes, that's correct.
And the alternative is another hypothesis to propose the null hypothesis should be rejected.
The alternative is the one that wants to challenge the null.
The alternative is the one that wants to challenge it, you said?
Yeah.
So you gather evidence that will reject the null hypothesis, right?
Okay. Okay.
And when it says gather evidence, it says to gather, like it's data. Is that where that's being gathered?
Yes.
So, okay, and then I guess I just didn't understand question number 3, and I don't know if you guys had other questions about.
I wasn't sure about that one
Yeah,
either, actually. I was actually kind of confused.
Are you talking about the type 1 and the type 2 error?
No, question 3, like filling in the box.
Yeah.
Like how we know how to fill that in.
Yeah, I just went over that this morning. Go ahead, Raquel.
I just filled it in when he explained it on the video because I still am not quite sure of why that's the way it is, and then like when they ask you, is this a type 1 or type 2? I'm not comfortable with answering that question at all.
Yeah.
Okay.
I do understand that the was it number 4, the level of significance is kind of the same as the type 1. So if it's small, the level of significance is small. And if it's large, the level of significance is large or larger.
Okay, I saw an example of the type 1, type 2. I saw an example on our lesson 9, how BYU Idaho doesn't allow the honor code. They don't allow wearing flip-flops. And say somebody wear a pair of shoes and it looks like a flip-flop, but it isn't. So the type 1 error is you're saying that it's a it's not a flip-flop, but technically it is. And type 2 is saying it's
They are wearing a flip-flop, but they don't get
I'm
judged for
kind of
it.
getting it flip-flop. Did you read that?
Yeah.
That
I was just
right?
remembering. So, okay, it all makes sense to me now.
That's the type
Okay.
1, type 2. Which one is more serious?
Which one's more of a risk? And so it's actually the one where
You know what?
I think I'm pretty sure it's more of a risk at type 2. Yeah, go ahead.
I was just going to say, you know how on the top of the table it says HO true and then HO is false? Maybe we have, like, in order to be able to say that the null hypothesis is true, so like the first box, because I had to look at the answer thing because I wasn't sure, and it says correct decision and then type 1 error. So is type 1 error, is that, it said something in our text about one of them being small or low and the other one being high. Do you guys remember that?
Yes. Yeah, the p-value.
Like the risk of it? Or, the p-value.
To be able to like reject it, or if it's true. So maybe type 1, if it resembles that, then the null hypothesis is true, and then if it is type 2, then that makes it false, and we can reject it at that point.
Yeah, you see the little table in there, the truth and the decision, and then the null hypothesis is true, and the null hypothesis is false, and then there's a fail to reject the null hypothesis, and below it, reject the null hypothesis.
Yeah.
That's the table we go by. And then right in the middle there, the null hypothesis is true. If it's a correct decision, then that's a type 2. And if it's a type 1 error, it's and the null hypothesis is false, then that's a correct decision.
Oh, okay.
That's the little table that we go by.
Go by? Okay. So that's how we read it?
Yeah.
Okay.
I know that this one really had twisted my head.
Yeah. I might have to wait till the group meeting to like see if you can better explain.
Yeah.
Okay, so then like let's move on. So 4 and 5, I think, on that one.
Those were pretty straightforward.
Okay, and then define the p-value. And then 7 is the null hypothesis is rejected in a hypothesis test. What is concluded about the alternative evidence? And we really don't have any sufficient evidence to conclude the alternative hypothesis is true. It's like, I don't know. That makes sense. Okay, and then what were some of your guys' examples of it where you've seen a hypothesis testing in real life? I had no idea. I could not even come up with one, so I was just curious what you
I
guys
have no
had.
idea either.
Are you a number 4?
Number 8.
Number 8, okay.
8.
You have a couple examples. No, I didn't come across any example.
When I was thinking about it, I was thinking about the examples in the textbook where it talked about the ship or the tour boat or whatever.
Yeah.
I was thinking that, and then they also did like the body temperature. And so I was thinking, well, when would they maybe want to test something? And I was thinking about, how in buildings there's like a certain amount of people that can be in like a room or whatever. And I was thinking, like, maximum capacity or whatever is like 50 people or whatever. And so I was thinking that they could probably, test something like that. Because, like, if, for example, if in a building they have a certain capacity amount of people and stuff, then, and if there was like a fire and the people couldn't get out, then maybe they would have to retest that in order to see if it was really, what was causing to where the people couldn't get out, if there was too many people or something like that. I don't know if that's what it was asking for, but that was the one that came to my mind.
Yeah.
Anything that had to do with, like, the status quo of something that's generally accepted as true, and it's not really questioned. But
Oh, when you explain like that, that's good. Thank you for that.
Yeah, they were saying that the average is 140 pounds per person. Then if that was the case, then why did the boat sink? I mean,
right.
Capsize. And it was because it was more than that.
Right.
So the alternative hypothesis was saying that it's greater than 140 pounds. And if it's equal to 140 pounds, then we're going to find out that both ends. And so we take that the null hypothesis will always be the mean that we measure everything against. Does that make sense?
Yeah.
Yeah, that makes more sense. Thank you.
So you're saying that the null hypothesis is everything that we'll test against?
Yes. So whatever your alternative hypothesis is, you take that's your X number, and you minus it the mean of the null hypothesis. And then you divide it, and also by the number of how many samples you have.
That makes more sense when you put it into that kind of perspective.
So what you're saying now, if we were looking at it with the z-score formula, the like the sample mean symbol is used,
Yes.
right? And that would be the null hypothesis, is what you're saying. And then we subtract the alternative hypothesis that we're making. Is that what you're saying?
The alternative hypothesis is your X number.
Okay.
And then you use the the null hypothesis as your mean. The mean from the null hypothesis is the standard, you know.
Got
That's
it.
what you're measuring
So
it
then,
up against.
it would be x as our alternative hypothesis, and you subtract the mean, which would be
The
the
mean of the
null
null, yes. Whatever it is, you know, that somehow they decided that like the temperature, the body temperature, you know, it's 98.6. And if you decided, no, it's not 98.6, it could be less, it could be more. That's why you have a equal sign with a slash in the middle. You know, you're saying that it could be either way.
Okay. Thank you.
The difference, right?
Yeah. But if you're
Okay.
saying that it's less than that temperature, that's when you have that, what, the you know, pointing the other way, less than. And if you're saying it's greater than, then you have it then. Then you're only checking the right side of it. If it's less than, you're checking the left side of it.
All right.
Okay. Thank you.
Yes, thanks. Okay, so should we move on to question 9?
Yes.
Okay, so I'm trying to see.
Do you want me to read it? The Graduate Management Admission Test, GMAT, is used as an admission criterion in many Masters of Business Administration MBA programs. The score on the GMAT in the past have a mean score of 529. The BYU professor feels now that the score has improved within the last couple of years. So, in other words, our null hypothesis, our HO, is equal to 529, but the professor thinks it's more than that. So our HA would be greater than 529.
Yes, I got that.
Okay, suppose you got evidence that the null hypothesis would be rejected. However, in reality, the mean score of students taking the exam is still 529. Was a type 1 or a type 2 error committed?
It's
So we
type
can go to our
1.
table.
I just remember looking back for the difference between a type 1 is when we reject a null hypothesis that is actually really true, and so it says that it was true, so then we can assume that it was a type 1.
It was a type 1, yeah.
I can't remember what example they gave for the type 1 and type 2 because I watched the other videos. I'm trying to remember, but it made me think of, oh, it's like someone getting convicted of something and whether they were innocent or guilty. Did you guys see that example?
Yes, I saw that example.
So that kind of helped me with that one, but with C, I had to look at the answer because I couldn't figure it out. But because it says if the analysis was done at the alpha equals 0.01 level, what is the probability of committing a type 1 error? And is that really you just look at that and that's the probability, you read that as the probability, and that's why you can say 1 in 100 chance or 1% chance?
No, I just look at my table. You know the table that we first talked about, the truth table? And that's where you kind of get it from.
Oh, I'm talking about C, sorry.
The C, okay. If the analysis was done 0, 1, what is the probability of committing a type 1 error?
I just don't really know how you can look at that and know that.
Well, yeah, and if it was 5, it would be
A 0.01
5
basically reject the null hypothesis. So
Is it, well, and like, didn't it say something like type 1, it has to do with the lower end, so like if it's 0.01, and then type 2 is when it's on the high end, is that?
I don't remember reading that, but I didn't go through the textbook with fine. I didn't go through it very closely.
I know. We were going through that. We spent a long time just trying to explain it to me, and it's going to take a while to gel because it seems like to me if it's a .01 is lower than .05, and .05 is really the standard. You know, if it's .05, it's enough evidence to reject the null hypothesis. But in this case, it was .01.
Is it okay if I read the type 1 and type 2 errors in our textbook real
Yeah.
quick?
Yes.
I'll read it out loud if that's okay, so that we all.
Go for it.
All right, so it says if the null hypothesis is true, for example, if the true body temperature of healthy adults is really 98.6 degrees Fahrenheit, sometimes we will get a very large or very small value of X bar. This will lead to a very extreme Z-score strictly due to chance. In this case, we would reject the null hypothesis even though it is true. Whenever we reject a true null hypothesis, we say that a type 1 error was committed. Assuming the null hypothesis is true, the level of significance, where it has in brackets the letter A, which is what we're looking at in our,
Yeah, the alpha,
is the probability of getting a value of the test statistics that is extreme enough that the null hypothesis will be rejected. In other words, the level of significance, the alpha A symbol, is the probability of committing a type 1 error. We choose alpha to be some small number so that the probability of committing a type 1 error is low. The most common value for alpha is equal to 0.05. That is equal to 1 out of 20. So when the null hypothesis is true, there is a 1 in 20 chance that it will be rejected at the 0.05 level of significance. Other common choices for alpha include A equals 0.1 and alpha equals 0.01. And so the type 1 error, it says that if the alpha is equal to 0.1 or 0.01, then there's the chance that it would be a type 1 error, the probability of it being that.
Yeah.
Where is that in the book? Is that under the body temperatures of healthy adults?
It's
Oh,
4.5.
it's right underneath. Okay.
Yeah.
Oh, I just want to make sure I can highlight this so I can come back to it later. Okay.
Yeah.
Oh, okay. So a large. Then it talks about something about like a large p-value is more likely to fail to reject the null hypothesis, but a small p-value it'll still reject the null hypothesis.
So the first one would be a what? Type 1 or type 2? A B, the B.
On B, it would be a type 1.
Okay. And the C?
Because it was rejected, but it's still true. And C, that was the one I was having a question on. It was like, how do we know that that's what the probability is of type 1 error? And I looked at the answer, and I'm just realizing it's just you read that alpha number, the 0.01 level.
Yes.
And that's the probability. So we just read it as the probability. So it's 1 in 100%, 1 in 100 chance, or 1% chance.
Yeah.
That you'd commit a type 1 error in this one. I guess I looked at it and like, how do I know what the probability is? And then
yeah, I had the same question.
Answer.
Yeah.
So what was the answer? The answer key on that one?
It was 1 in 100 or 1% chance.
Okay, yeah, I got that. Yeah. Okay, if we want to decrease the probability of making a type 2 error, would we need to increase or decrease the level of significance? If we want to decrease the probability, okay, then we need to increase the level of significance if we don't want to have a type 2 error. Because when we increase it, then the null hypothesis will not be rejected.
So if we increase, I like to write down notes.
Okay, if we want to decrease the probability of making a type 2 error, would we need to increase or decrease the level of significance? We definitely would need to increase it.
Because the level of significance affects type 1.
Yeah.
So does that mean that the opposite would be true. I don't know if this is right, so you can correct me if I'm wrong. So if we're saying that in order to decrease the chance of making a type 2 error, we have to increase the level of significance. So can the same be said about type 1 if we want to decrease the type 1 error, that we would decrease the level of significance?
We would decrease. If it would be decreased, then the alternative hypothesis would be right. You know, that's the part I'm really confused on that one.
Yeah, I'm still trying to grasp the table that we went over. So, okay, we can move on if you're ready.
The National
He
Association.
actually explains that pretty well on the video.
On the PowerPoint video or the homework or the preparation? Oh.
The homework answers, because basically type 1 and the level of significance are kind of the same thing. So if it goes up, type 2 has to go down. If type 2 goes up, type 1 and the level of significance.
So it's kind of
They
like
kind of balance each other out, but he explains it way better than I can.
No, that's really good. Thank you.
So if the other one goes up, the other one goes down. If the other one goes up, the other one goes down. So it's like a seesaw.
He says it's like a balance machine thing.
Like a teeter-totter?
Oh?
They can't both be up at the same time.
Okay. Thank you.
Oh, I feel like I read that in like that video. He gave like an example. Oh yeah, when one probably goes up, the other goes down. Okay, that makes more sense now. It's like I write down these notes, but I don't really know what they mean.
Well, it'll take a while, it'll gel.
I know, I'm like, I need to be more like for now and just read and read and read the question. I just kind of go through it real fast because I'm like, I don't have time. Okay, so are we good for question 10?
Yep.
Okay, so I'll read it. So a study by the National Association of Realtors reported in 2004 that second home sales accounted for more than a third of the residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. Assuming the national standard deviation was 5, a real estate agent wants to determine if the average age of those buying investment properties in this area is different than the national average. He randomly selects 15 of his clients who purchase an investment property and obtains the values. So question A, it says, design the study. What is the population from which the realtor obtains the data? How did he sample this population? So I'll just answer it. He collected the data from the population in the second home. The sample he got was from his own clients, and then his research question is the average age of the people buying a second investment property in my area different than the national average? So that was just kind of like depicting from the question. Did anybody have questions on that one?
No, that was
straightforward.
Because he was just comparing his area to the national average. So we assume that the national average is the null.
Yeah, that's kind of what I assumed. So what ways did you guys say like he could have randomly selected his sample for question B?
Okay.
I don't know. Okay, go ahead.
I'm going to put that up. I use my Google Sheets to do that one because when I was over at Wanda, I did not have my my laptop. So I basically enter all the age into my field, but it's much better if you do it in your SPSS.
Yeah.
Because I literally have to figure out the average age. You know, it was 46.733, and the median was 49. Anyway, I figured out all of that, and then I take 46.73. As it turned out, remember when I texted you, it was the answer was what was it?
209.
Yeah, 1.209. As it turned out, because I only used 46.73, if I had used 46.733, I would have arrived at the same answer that the answer key had. But I only used 46.73.
For what number are you talking about?
That's what
Then
I
when you
used
make
to.
the inferences. Sorry, I jumped too much ahead. Sorry.
No, you're good. I just make an inference. I just was trying to see which one you're at.
Okay, we're on the number 10, but number 2 is collect the data and name at least one way the realtor could have randomly selected his sample.
I put down, like, the various sampling methods that we've gone over or whatever. I was thinking, well, maybe he could have done a cluster or maybe stratified, since those usually are the popular
I
ones.
put stratified. But I was also, my thought was like, oh, he could do a cluster too, though. So I think there's a lot of different ways he could have done this.
Maybe that's what it's trying to get
Yeah,
at. There's other options.
I chose it's systemic from his personal client list, starting with number 2, then choosing every 5th client.
Yeah.
Yeah.
Yeah, that's true. That's a good one. I think really any of them could work for the most part.
Did you put it into
Yeah,
a
on the tutor video, it said that he could even have written their names on a piece of paper and put them in a hat and draw them out.
Yeah. As a result, I look at his data in a histogram. It was left skewed.
Left skewed. Yes.
So for sorry, so are we on to letter D now?
Yeah, make inferences.
So
Check the requirements. Since there are only 15 pieces of data, what will you need to check? Needs to be normal, so you need to increase the sample. He should have had more than 15 samples.
I put less than.
If you want it to be approximately normal.
isn't it you want to have like at least a sample of 50 or 30?
30, yeah.
30, that's what I put.
So when it says to check the requirements, and since there are only 15 pieces of data, what would we need to check, though?
I watched the example, like the answers when that guy goes over the question key or whatever.
Yeah.
And he said something about like you have to have a Q plot.
Oh. So you check
I didn't,
plot.
because I didn't understand why we had a Q plot.
Does that help determine if you're distributed correctly?
Well, that says if it's normal or not.
Okay.
Okay.
So I think, isn't it if it has a smaller sample of 30, you have to go and use a Q plot? I'm pretty sure that's what he said.
That makes sense.
I can't remember exactly, but he's like, that's why you go and check with a Q plot. And then you can check. I can share my screen. I just copied the example. Probably should have done that, but.
No, it does. It makes sense what you're saying about how to check the QQ plot, because I remember how what Raquel was saying, how it indicates if it's normal or not. I remember that in the past.
And so you can see that those lines, they're sporadic clusters. And so that's just more of a visual, so we can all see that. That's just what.
Oh, thank you. I appreciate it.
Example. So.
Thank you.
Right there. Okay, and then state the null and alternative hypothesis.
Okay.
This one was, is it a one-tailed or two-tailed test?
So you find the z-score, which is 46.73, which was at the bunch of 15 numbers that he put. His average, which his mean, was 46.733, and then you minus the null, which was 47. Divided by 5, which was the standard deviation, the square root of 15, because he had 15 samples.
Find the difference. Is that what you guys got for the second part?
Yeah,
Yes.
that's what I put down, not equal.
Okay. And then we have that what is that? Is it the probability is 0.05 or the alpha?
Yes.
AB. Okay. I just want to make sure I'm reading it right. And so then compute the statistic. Did everybody? I got the answer. My thing was I just went ahead and I didn't use the the 5-number plot. So I was like, I don't know where they're getting this number. So I had to watch the example. But I got it.
Yeah, that's what the one I talked in the beginning. If I put down a 46.77733, then I would have come up with, minus 0.207.
I did the same thing you did, I got 209. And I think in the answer on the video, he got 209 too.
Yeah,
The answer
2091.
7, and the reason why they had 46.733. If you put down 46.733, you will have arrived at 0.207.
Yeah.
Okay, well, even on the answer in the video, he comes out with 2091. 0.2091.
Yeah,
Well,
that's what I.
They said round it to just 3 numbers.
Well, you can round it to 4. You can have 4 numbers because it'll just automatically round it.
Yeah.
In the applet if you use that. So really, you could do either or.
But just looking at the number itself without having to do anything, you know that he can't reject the null hypothesis.
Because his mean was so close. Right?
What was it? I'm sorry?
Because his mean of the 15 samples that he had was really close to the null hypothesis. Because it was at 46.73. I mean, he only had like 0.25% off.
Well, I don't think it has to do with that because the other one, it has to do with his sample, I think. But you're right that it's good logic to look at it. It's not too far away. It's almost 47, really.
Yeah, if you round it, it becomes 47, right?
Right. If you round it to the nearest full number.
Yeah.
And then you just take that negative score and plug it into the applet.
Computer test results.
Hi.
And then we put it in and compute the p-value. Let me go to my applet.
I got 0.8344 because you looking at both the left and the right tail.
Yeah.
That's what I got too.
Yeah, I got 8344, but the thing
The
got
answer
it
was slightly different.
because it used it was 8360, wasn't it? And the only reason why they got that because they used 0.733, 46 point. That's why theirs was slightly different.
Oh, 0.836.
Yeah. That's why theirs was at .207 and not at .209. We use .73, but they use .733.
That makes sense. Okay, well, we're sorry. I'm just looking at the time. It's 8:51. I just have to get off probably within the
Fine.
next 20 minutes.
Do you want to start the exam? Or the not the exam, sorry, the quiz.
The quiz, yeah.
Good. Do you guys wanted to do that?
Let me log in.
Sorry, I'm not trying to like rush everybody.
No, you're totally fine. 21 questions.
Okay. I'm moving like molasses on a snowy day. Okay, group quiz there. Okay.
I'll be right back.
Save. Okay, I got the normal applet. Okay, which hypothesis involves equality? It's going to be the null. The null is always... Somebody went somewhere.
Emily just went somewhere for a second.
Okay.
Hey, sweetie.
Are we on
Okay.
4 now?
It's fine.
I can't.
Okay, so which hypothesis involves equality? And that's the null hypothesis, right?
Yep. It's always the one that's equal to whatever it is.
Yeah. So then the p-value is the probability of obtaining a sample statistic at least as extreme as the one that is actually observed. So question 4 is, remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis? Is it the null hypothesis usually assumed to be true?
Yeah, and it's equal.
Yeah.
Okay.
The null
Sorry,
hypothesis.
I just spot on. Okay. So question 5, suppose the null hypothesis HO is equal to 10. So use this answer to, or use this information to answer the next 3 questions. So which of the following represents the alternative hypothesis for a two-tailed test? And that's the one that, the third one?
Not equal. Yeah, not equal to.
Yeah, not equal
Not
to.
equal to. Yeah.
So a left-tailed test would be the first one.
A
Because it's less
two-tailed
than.
one.
Less than.
Okay. Did we finish with number 5?
Yeah, we said it was the third one.
Yeah. 6.
And then 6 was the that's the less than sign is the first one, right? I always forget.
Yeah, the first one.
Okay.
Oh, this is easy.
Okay.
The right tail is number 2.
Yeah, because it's greater than. So remember that we determined the outcome of a hypothesis test by comparing the p-value to the level of significance, or alpha. Use this information to answer the next 2 questions. Which relationship would result in a failing to reject the null hypothesis? Oh man, I don't know.
The p-value is less.
So the p-value is compared to the level of significance. is also equal to a type 1 error. If a type 1 error,
So HO is true. Or I don't know. I'm confused.
Where are you?
okay, so if it's compared to the level of significance to the alpha is also equal to a type 1 error. So I think it's between 1 and 2.
Okay, what number are you guys on?
Number 8.
8.
Oh, I've moved on, sorry. Which relationship would result in failing to reject the null hypothesis? That would be A. Wait a second.
I think it would be the greater than. It would be the first one, wouldn't it?
Yeah, which relationship would be failing to reach? Yeah, it would be A. Because it's greater than
Because if it's smaller, then the null hypothesis would be rejected, and so
Yeah.
it would be the first one. Oh, okay, we're
Right.
good.
first one.
You guys good with that?
Yep, I am.
Which relationship would result in rejecting the null hypothesis? The B. I'm sorry, B.
Number 2, right?
It would be
Yeah.
the less than. Yeah, that's perfect.
An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use this information for the next 2 questions. Which of the following would be appropriate alternative hypothesis?
Is greater than.
Would it be 3, the average
What's 3?
claim is greater? Or the alternative?
I think it would be the average claim amount is greater than 1,500.
Because it says it's actually higher than this.
Yeah,
Yes,
that's
the
what I
greater
chose.
than 1,500.
Yeah, it'd be greater than.
Which of the following would be the null hypothesis? Is the average claim amount is equal to $1,500?
That's what I put.
Okay. So then
Yeah.
question 12. The insurance company randomly selects 40 claims and calculates a mean of X bar of 1650. Use this information next to questions. So 12, we have the insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? Yeah, because it has a higher.
I would say yes.
So I would say yeah.
Over 30.
Because the
Yeah.
sample size is large.
That's what I think.
40, yeah.
Is the population
over
normal
30.
too? Manually?
If it-
Oh, it doesn't say.
It doesn't say anything about population.
But if the sample
So
size
it's-
is large, then it is. If it's over 30, right?
Yes.
Yeah.
Okay.
So then 13 is what theorem or law justifies your answer to the previous question?
CL.
Is central limit theorem right? The larger
Yes.
the sample size?
Talking
Okay.
shape.
I thought it was CLT.
Yep. Central limit theorem.
Yeah. Yeah.
Which of the following is the test statistic as defined in this lesson? Oh man. Is that the X bar?
That was my first guess.
X bar is the sample means. Which of the following is the test statistic?
Test statistic. Blah, blah, blah.
Is it? I use one of them for vinegar. That
That's
one
what-
underneath the sink is under the vinegar. The bathroom sink.
It's C, you said, Raquel?
It's Z.
It's C. So it's B.
It's Z because where the number
What?
was.
What does S stands for?
That. That's a good question. I'm not sure.
So wait, what is it? Is it B?
He said that in the video.
That the
That the
test is
z-score is the statistic.
The X bar stands for sample mean.
okay.
The green one.
Z stands for z-score.
Yeah.
The S stands for standard deviation.
Probably took it because it said yesterday.
Okay.
And N
I'm gonna.
is
It says.
the sample.
Yeah, I think Raquel is right. I think it is the testis. That's the. I can't say. Okay. Sorry. I'm going with what Raquel said.
Okay, wait, what
Z.
question are we on?
We're on 14.
Oh, okay, sorry, I missed part of that. So it is the Z.
Yeah, she said that in the video that it said that it's the test statistic.
I just wasn't sure if that was a Z-score, if that's what it was. Okay. So, are we good to move on?
Yes. Yes, if somebody wants to go back and go through their tests like I always do, it's okay.
Perfect. Okay, so the historical mean of sales receipts at a grocery store is 150 with a standard deviation of 40. The store manager suspects that the average has decreased. She sets up the hypothesis with these hypotheses. She says that it's equal to 150 and the alternative is less than 150. She'll use the level of significance as 0.05, and then she'll take a simple random of 36 sales receipts from her store and computes an X bar of 144. So what's a Z-score associated with the test? So let's set this up.
Okay.
144 minus 150.
Okay, so a mean minus, or is it the value minus the mean? Divided by
36.
40, 36.
Great.
Okay, I got negative 0.899. Bless you.
Thank you.
Oh my gosh. What did you guys get?
I got negative 0.899.
Negative 0.89.
Because what did you get for the top part of doing this, the mean? Is that what you got?
Yeah, 144.
Yeah, and then 40 divided by the square root of 36, I got 6.66666. So when I divided the negative 6 divided by the 6.66666, I got, I guess it depends on how you do it. I got 0.9.
Okay.
Yeah. Oh, you want to go bye-bye?
I got a way different number.
Yeah, you want to go bye-bye? Sorry, guys, I'm talking to my son, not to you guys.
No, you're totally fine. I think I set mine up wrong. How do you guys set yours up?
So I could show you.
Okay.
I set mine up 144 minus 150 divided by 0.05 divided by the square root of 36. I got a number that. Huh?
The standard deviation is 40.
Okay.
Oh, it's
Should
3,
be
not 5.
40. It should be 40 divided by square root of 36.
Yeah, yeah.
Thank you.
That's where is the. That's what was the standard deviation?
40.
40.
That's why mine was. Oh my gosh, it's right there. It's 40.
Okay.
Sorry. That's
No,
like
you're
a.
fine. Okay, I actually got my z-score as 0.9. You want to go bye-bye? Okay,
That's
wait.
why
The
I
thing
gave
is
you
so
a number.
different because I did 144 minus 150 is negative 6. And then 40 divided by the square root of 36 is 6.66667.
Okay.
Like lots of sixes.
6 divided.
I don't know how to see if I just take it out 3 places.
You're right. It's
It changes.
0.899. Or point if you round it off.
It says 3 decimal places, so I don't know.
So you'd wind up with 810 if it was 3 decimal point. Wouldn't it?
You're rounding.
Divided
You would
by
need, because if the 9 bumped up the hundredths place, it would bump that up, that 10, to the 8, which would make
okay,
it.
I got the same answer as Melissa.
Sorry, guys. What'd you guys end up getting for 15? Did you get
The same
0.9?
as you.
Shall we just put down
I got
0.899?
0.9 just 15.
So did you guys put down 899 or 0.810?
Well, depending on how I rounded the bottom, sorry, I got 999 or I got 0.9. So I'm not really sure.
I got 0.9.
Okay, so I redid it again.
Just
All of
rounded
it.
the bottom. Oh,
0.9.
Okay, come here.
I did a 6.66.
Because when you round the other one, it'll have the domino effect.
I
The
think
third
so.
9. And that goes up to, yeah, it is 0.9. You're right. So let's go and look at the p-value. Minus.
It sucks. So
0.368.
I got 0.1841.
Negative point.
That's right.
But that's when I put it in.
It's wanting us to, they want the probability. The p-value, which is the number up on top.
But we have to do the.
Okay, back on 15. I'm just right. I got a negative number. Did you guys get a negative number?
It shouldn't be negative because you're looking at the probability. You're just looking at the left side because it's less
Oh,
than.
that was
Unless
the
it's less.
Z-score.
Oh, were you talking about the
So
z-score?
on number 15, I didn't hear anyone say negative, but I think it should be the negative number.
Yeah, it is a negative number. Thank you.
Okay.
Yeah, the z-score is
So
negative
now,
0.9.
and then we just
Now put it into the applet. You put negative 0.9 in the applet. Sorry,
Yeah.
guys, I'm trying to change my son right now. He's sneaky.
That's how you get the 3.36. That's your p-value.
Okay, we'll go bye-bye.
negative
116.
0.184.
When you
That
put
was
in
yours,
your
huh?
minus 0.9 at the applet, You get a
Yeah, and it should be 0.184.
What did you get? Oh,
Okay, that's what
I
I
got
got.
I got 0.184.
That's what I got.
I shaded both sides. That's why mine was wrong.
Yeah, because we're just looking at the less than, the left tail.
That's the mistake I made at the exam.
Oh, sorry, guys. Can say hi. Are we all done with 16?
Yeah.
Okay. Sorry, I'm just trying to hurry up and get him dressed. He's wanting to, we have to be somewhere at
What
9:30.
inference?
Failed to reject the null hypothesis.
What inference would you make?
Failed to reject.
Fail to reject.
Ouch.
Yeah, because it wasn't 0.05. It was 0.9. It was higher.
Okay.
We have sufficient evidence. What is your conclusion? We have sufficient evidence. No.
Is it?
We have insufficient evidence that the true population is less than, yeah, insufficient.
It's less than. So it's C.
Is less than?
Little one.
I'm so sorry, guys.
Don't worry about it. I have a
It's
pretty
sufficient that it's less than.
Okay, I'm just gonna mute my. my
No, it's okay. Don't mute it.
He's just fighting.
Okay, are we on number 19 then?
Yeah, we're number 19.
Okay.
There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the hypothesis when the null hypothesis is true?
Would that be type 1?
Here you go.
Type 1? Type 1.
If it's failed to reject, I thought that was a type 2. The null hypothesis. Is that right?
I don't know. I'm not sure. I get them. It's hard with this table.
Type 2 is where it is committed when we fail to reject a null hypothesis that's not true.
Okay, so then would it be type 1 that we rejected, but that the null hypothesis is true?
Well, did we? Hold on. Let me go back. Sorry. We failed to reject the null hypothesis. So, yeah, it's a type 2.
I thought it was a type 2.
Yeah, it's a type 2 because we failed to reject the null hypothesis.
Okay.
I don't know, because if you look at the chart and you. Oh, no. Which one involves rejecting?
All right, 2 more. Ready to go forward or?
Let's do it.
Yeah, let's do it.
All right. So a researcher decided that instead of using a level of significance of alpha equaling 0.05, he will use alpha equaling 0.01. Which of the following will be true?
So, would it be the type 1 error will increase? Sorry, I gotta answer. This is my husband.
No, you're fine.
I think it's the first one. Hey.
I think that's the first one.
Okay.
The probability of type 1 error will increase. Can you explain why it's a type 1? Because it take me a long time to think about it.
Yeah, I'm looking at the whole work. Because there was a question like that on there.
Okay. Are we still on 20? I'm sorry. I have to go unlock my car.
Yeah, we're still on 20.
Okay, so
Okay.
decided instead of using a level of significance, he will use 0.01, which I found true. So, I'm going to go back to my notes.
If we wanted to decrease.
Null hypothesis is equal to the normal status. Probability that the null hypothesis is true will decrease. Isn't that false?
He's so cute.
We go to this play group at 9:30, and he knows, like, and he brought me his shoes, and he's like, "Let's go, Mom." So he's a little crazy because
What's the hold up?
oh, he's mad at me. He wants to go. Okay, you have the keys. I just gave him my keys. It's dangerous.
I think it's A.
Yeah.
Okay. Oh, okay. 21.
Oh,
Because
okay,
on
it
the
is A, 'cause
homework,
it's-
it asks if we wanted to decrease the probability of making a type 1 error, would we need to increase or decrease the level of significance? And the answer is decrease. So if you want to decrease the probability of making a type 1 error, you would decrease the level of significance. And
oh shoot.
did he increase it or? I don't know, this is. Do you guys have number 10 done on your homework?
I haven't done my homework yet. I haven't had time.
Well, the answer is decrease. I think that we can use that question and figure this one out.
Okay. A is equal to 0.05 to increase the probability a type 1 error. Decimal point.
Isn't it
So
just
he increased the probability of a type 1 error. So it's 8.
so are we on 21?
Yeah.
If A equals alpha equals 0.05,
Okay, I'm so sorry, guys.
So do I just put that into the applet?
You're okay.
The area is 0.05.
Poor guy.
Sorry.
Go play.
He's already. I know. He brought me his shoes to go, and I'm like, hey, look, I can play with the keys right here. Sorry, he just wants to take my keys out and put them in the water, so I just don't want that to happen.
Right.
He's mad at me. Okay. Okay, don't go outside.
Okay, are you guys doing that last computation?
I'm trying to figure out how to do it. Hey, Jen,
Do we put it in the area of the applet or in the z-score? The A. I know the probability of 0.05 is 1 because it said it somewhere earlier.
5 increase the probability that a type 1 error. Is it 1 over 20?
Well, isn't it
On one of the
50%?
other questions, it said that
0.05 is 1 over 20.
0.01 is 1 out of 100. Figure that out.
Are we overthinking this one?
So 0.20, 20%.
Is it 0.20? 0.2?
Well, 'cause
Hey, Wanda? You know that very last problem on the quiz?
Yeah.
Alpha is equal to 0.05.
Hey, we're
It
gonna be
says
gone in a
compute the
second.
probability of committing a type 1 error. It's round to the decimal point. That's 1 over 20, isn't it? It's a 0.2? We were overthinking that one. It's 0.05. I thought we were overthinking it.
Yeah. Yeah.
Yeah. Okay, so it's just 0.05. Okay.
Okay.
I was thinking it's the same as 1 over 20.
Well,
We were really
just saying that because that's the probability. Remember in the other question on our homework, it said 1 in 100 chance because it was 0.01, or it was 100% chance, or
it's 0.05. Okay.
it's just 0.05.
Yeah, that was the same one I was talking about. It said
Yeah.
it was 1 in 20.
Sorry, I missed that. I was dealing with my son.
No, you're good.
0.20.
Oh, okay. The type 1 always matched the alpha. Okay. So
Yeah,
that
'cause
means
the
that
level is
it's always
significance.
true? Okay. Gotcha. Thanks. Okay.
I'm going to submit it.
You can submit it, and then you can end the broadcast so you can go, because your son.
Yeah, I'm sorry, guys.
No,
Okay.
you're fine.
We missed 2 of them.
Okay.
Okay, yeah. I'm so sorry. The 2 that we missed are
I gotta go, guys.
is 19 and 20, but it's pretty much self-explanatory. So, yeah.
Okay.
Okay.
All right. Have
I will
fun.
see you guys later. Thanks. Sorry, guys.
Bye.